All right, number 15 gets its own video. It's a big problem, puts together a lot of what we have been talking about over the semester. So to get started, it says solve the inequality. Remember, an inequality is going to involve setting up a number line and then testing intervals. So we need to find critical numbers, and critical numbers come from where we are equal to 0 or where our function is going to be undefined. So looking at our original typed inequality, we're going to have problem spots at -4, can't divide by 0, and 5 halves, which is 2.5, just for reference sake, on a number line, because that's what would make the denominator 0. So that's going to be our undefined values. The next thing that we want to do is we want to start figuring out, well, where does this inequality become equal to 0? So we're looking for our equal to 0 situation. I'm going to start by subtracting the 1 over 2x minus 5 to the left side so I can start to find the other critical number. So I've got 2 over x plus 4 minus 1 over 2x minus 5. Maybe. Wait, it just never gets any better, does it? You guys are sick of it. Trust me, I'm sick of it. 2x minus 5 less than or equal to 0. Next thing then is I need to find that common denominator. This fraction needs 2x minus 5, while this fraction needs x plus 4. So this one I'm going to get 4x minus 10 over 2x minus 5, x plus 4. Minus this fraction, I'm going to get x plus 4 over 2x minus 5, x plus 4, and we are still making a comparison to 0. Cleaning up across the top, I'm going to have 4x minus 10 minus x is 3x, negative 10 minus 4 is negative 14, all over, not 3, 2, 2x minus 5 and x plus 4, figuring out less than or equal to 0. Well, we already figured out the problem at 5 halves, the problem at -4. We then will be equal to 0 when x is 14 thirds, because a fraction is equal to 0 when the numerator is equal to 0. So I found my 14 thirds is going to need a closed circle. 14 thirds is going to be 4 and 2/3, because 14 divided by 3, 12 divided by 3 is 4, with 2 remaining. This gets a filled in circle because this is a equal to 0. So this is a critical number from being equal to 0 versus -4 and 5 halves were from where we were undefined. So we can't use those. All right, so then a question that often comes up is where should we sub back into? And it's kind of up to you. You want to make sure you're subbing into something that still has the denominator in its full force. So don't cancel anything. Don't just sub into the numerator. This would be a good place to sub in. You also could sub into the original though and figure out true or false, and that's fine too. I'm going to clean up my slide a little bit. We're done with this. We're done with this. I'm going to move this up here. Don't mind me, just shuffling, just so I can see things a little bit better on my screen. All right, so I've created 4 intervals that I need to test. I've got this red interval, this yellow interval, this blue interval, and this green interval. So I'm going to pick a number from the red interval. The number I'm going to pick is -5. And if I sub -5 into the numerator, okay, into the numerator, I would get 3 times -5, which is -15, minus 14, which creates a negative number. -5 into 2x minus 5 is going to be -10, minus 5 is a negative number. -5 into x plus 4 is -5 plus 4, which is a negative number. And a negative divided by a positive is overall a negative number. Are negative numbers less than 0? Yes, so that one works. Next then, in the yellow interval, I'm going to pick a number between -4 and 5/2. I'm going to pick 0. When I plug 0 into the numerator, 3 times 0 is 0, minus 14 creates a negative. 0 times 2 is 0, minus 5 creates a negative. 0 plus 4 creates a positive. Negative divided by a negative creates an overall positive value, which is not less than or equal to 0. Pick a number between 2.5 and 14/3. I'm going to choose the number 3. If you sub 3 in, 3 into here creates a negative numerator, a positive first term in the denominator, a positive first term in the denominator, or second term in the denominator, a negative divided by a positive. This is just one giant line to show you the overall result. This creates a negative. Negative numbers are less than 0. That one works. Last one then, a number greater than 14/3. I'm going to choose 5. 5 into the numerator becomes negative. Into the denominator, we get, 5 into the numerator is positive. 3 times 5 is 15, minus 14 is positive. This is positive. This term is positive. A positive divided by a bunch of positives is still positive. The positive numbers are not less than 0, so that one is no good. Your final answer is supposed to be in interval notation. So I need to take the winning intervals, -infinity until -4 with a parenthesis, and 5/2 until 14/3 with a bracket. These were my winning intervals. Pick any number in those intervals, and this mathematical sentence will be true. This one is a lot, okay? The biggest thing is to remember you got to find not only the zeros and do the number line, you have to make sure you're talking about the undefined values from the denominator. And then the biggest thing is, where do you test back into? And again, I think it's easiest to test, erase this, easiest to test into this simplified version as long as you still have this denominator present. Make sure you haven't canceled anything out along the way.